Hello everyone, welcome back to this channel. My name is Jyoti and I am a CMA finalist. This is our third video on linear programming, and in this video we are going to solve LPP using isoprofit method. So let's just have a quick recap of the steps involved in solving the LPP problems. The first step is to formulate the LPP to get objective function and subjective constraints. The second step is to draw the graph for each of the constraint. For greater than or equal to type, the region will be above the constraint line. The greater than or equal to type is nothing but minimization problem. For less than or equal to type, the region will be below the constraint line. Less than or equal to type is nothing but the maximization problems. Okay, the third step is to find the feasible region which satisfies all the inequalities. The fourth step is to solve the LPP using isoprofit method. Okay, let's just solve a institute study material problem. This is illustration number 5 on CMA Final SEM study material. So let's look into the question. Solve graphically the following LPP. Maximize m is equal to 50x1 plus 60x2. Subject to constraints. 2x1 plus x2 is less than or equal to 300. 3x1 plus 4x2 is less than or equal to 509. 4x1 plus 7x2 is less than or equal to 812. x1 is greater than 0, x2 is greater than or equal to 0. Moving on to the solution, of course we can identify the decision variables x1 and x2. They have given us the objective function m is equal to 50x1 plus 60x2. Our next step is to draw the graph. For this purpose, we have to find the value of x1 and x2 for each of the constraint. So if we take the first constraint here, which was 2x1 plus x2 is less than or equal to 300, we are going to send this 300 to the left hand side to find the values of x1 and x2. So 2x1 plus x2 is equal to 300 becomes 2x1 divided by 300 plus x2 divided by 300 is equal to 1. So the value of x1 here becomes 150 and the value of x2 here becomes 300. Yes. For the second constraint, which was 3x1 plus 4x2 is less than or equal to 509. If we send this 509 to the left hand side, it would become 3x1 divided by 509 plus 4x2 divided by 509 is equal to 1. So if we cancel it out, the value of this becomes 169 point. It is going to be 66666. So we are going to round it off and write 0.67. For the value of x2, it would become 127.25. So these becomes our coordinates for the second constraint. For the third constraint, which was 4x1 plus 7x2 is less than or equal to 812, if you send this 812 to the left hand side, it would become 4x1 divided by 812 plus 7x2 divided by 812 is equal to 1. So if we cancel it out, we get the value of 203 for x1, and for x2 we will get the value of 116. For the fourth constraint, which was x1 is greater than or equal to 0, the value of x1 automatically becomes 0. This is going to be lying on vertical axis, which means if this was a graph, if the value of x1 is equal to 0, here would be 0. The line for the fourth constraint is going to be lying on the y-axis. As for the fifth constraint, which says x2 is greater than or equal to 0, the value of x2 automatically becomes 0, and this is going to be lying on horizontal axis, which in this case would be the x-axis. Now that we have found the values of x1 and x2 for all of the constraints, we are going to draw the graph. Here I have already noted down the values of x1 and x2 for all the constraints. Now let's look at the graph. In the graph, they have taken the values of 100 and 200 on the x-axis. They have taken the values of 100 and 200 on the y-axis. Now they have drawn the graph. Let's do the same. For the first constraint, the value of x1 is 150. So we will go to the 150 on the x-axis and we are going to write it down. And the value of x2 is 300 and we are going to also write it down, and then we are going to draw the line. See, here in our textbook the values are only given up to 200. So I have extended the y-axis so that I could be able to draw the line for the first constraint. Fine. So for the second constraint, the value of x1 is 169.67. So we will go to the x-axis and we are going to find 169.67. And we are going to plot it. And the value of x2 is 127.25. So we are going to go to y-axis and we are going to find the value and we will go to plot it. And the next thing is we are going to draw the line. For the third constraint, the value of x1 is 203. So on the x-axis we will go to 203 and we are going to plot it. On the y-axis the value of x2 is 116. We are going to find it and we are going to plot it and draw the line. Now that we have drawn the lines, we have to find the feasible region. For greater than or equal to type, the region is going to be below the constraint line. So this being the maximization problem for the constraint L1, all of this area right here is going to be the region. For line number 2, all of this region is going to be the region. For line number 3, all of this area is going to be the region. So if you observe correctly, the shaded area that is given in our textbook is nothing but the feasible region, which was satisfying all the constraints simultaneously. That means here the point O, F, H, J and C are the points representing the feasible region. Fine, I am going to clear this up. If this was corner point method, we would have taken the coordinates of O, F, H, J and C and we have substituted these values in the objective function. So whichever gives us the maximum value, we could have considered it as a solution. However, for the isoprofit method, we are going to draw the isoprofit line and we are going to move that across the feasible region, and the coordinate that is furthest from the origin is going to be our solution. To draw the isoprofit line, we are going to assign an arbitrary value to the objective function so that we will find the values of x1 and x2. So let's see how we do that. The objective function was m is equal to 50x1 plus 60x2. So maximize z is equal to 50x1 plus 60x2. This being our objective function, let me just give an arbitrary value to it. That means let's say the objective function was 6000. 50x1 plus 60x2, this would become our equation. We will now have to find the values of x1 and x2. So for this we will write 50x1 divided by 6000 plus 60x2 divided by 6000 is equal to 1, which is going to be, here it would become 120. Here the value of x2 becomes 100. right? This way we will find the values of x1 and x2, and then we are going to draw the isoprofit line. Just give me a second, I'm going to draw the isoprofit line. So here there is 120 on the x-axis, and here on the y-axis we found 100 and we drew the line. Yes, this line is the isoprofit line. The next step for us is to move this isoprofit line across the feasible region, and the point of the feasible region which is furthest from the origin would be our solution. So for this purpose I am moving it across the feasible region. The first thing that I am touching is point F. The next thing that I am touching is point C. The next thing that I am touching is point H. And the last I am touching point number J right here. So J is the point of the feasible region which is farthest from the origin. Because this is a maximization problem, we are going to find the coordinate which is farthest from the origin. If this was a minimization problem, we could have considered the point which was closest to the origin. Yes. So here the point J is our solution. So we have to find the value of J here. So the value of J here is on the x-axis it would be something like this, and on the y-axis it would be somewhere here. The thing is that in the solution they have already given us the value of J, which is 138.2 on the x-axis. That means here it was 138.2, and on the y-axis right here it was 23.6. Now this was the value of x1 and this was the value of x2, which was our solution. The objective function was to maximize z is equal to 50x1 plus 60x2. So if you substitute the values of x1 and x2, we get the answer of 8326. This may sound a little bit confusing because we don't have the real graph here. But if you have a real graph, it would be fairly easy for you to plot the lines and to find the solution. So this is it for this video, guys. In the next video, I'm going to discuss about the simplex method. In the meantime, why don't you comment down below about your study plan? Don't forget to like, share and subscribe if you're liking the content. Thank you for watching.